So good morning, everyone. Welcome to our panel session. And I know that it's just an incredible title and you're all pumped up and waiting to see what we're going to talk about. Supercharging the software factory, deploying capability at the speed of relevance. Next one. So let me first start by introducing the panelists. You already had a chance to meet Dr. McQuade yesterday morning. He is not only the CMU Vice President for Research, but he's also the co-chair of the Defense Innovation Board's Software Acquisition and Practices Study, or as we lovingly call it, DIB SWAP.
DIB SWAP.
Yes. So Dr. McQuade. The next panelist is Dr. Forrest Shull. Forrest wears a number of hats at SEI, but the most current one is that he is the lead for the defense acquisition policy work, spending a lot of time at the Pentagon, thank you, and at the Mark Center. So welcome, Forrest. And another special guest, Mr. Andrew Kemendo. Andrew is, I thought he was at Kessel Run in Boston, but I just learned that he spends a lot of time in DC and at Kessel Run in Boston. But he's the Chief Data Officer there at Kessel Run. So we've got an all-star lineup here, and we're gonna have a lot of fun talking about some key topics. So I wanted to just set some context first. It's a statement from our previous Secretary of Defense, Jim Mattis, and it's from the National Defense Strategy. Success no longer goes to the country that develops a new fighting technology first, but rather to the one that better integrates it and adapts its way of fighting. Our response will be to prioritize speed of delivery, continuous adaptation, and frequent modular upgrades. We must not accept cumbersome approval chains, wasteful applications of resources in uncompetitive space, or overly risk-averse thinking that impedes change. I really thought that it was an incredibly appropriate quote, and it really sets the stage very nicely for our panel discussion, but more importantly, for the whole software transformation that's underway. So, just a few key points. The DoD need for software engineering has evolved and intensified. Software is a national defense priority, but if this is true, the DoD must be able to develop, procure, assure, deploy, and continuously improve software faster than our adversaries. And we hear a lot about the ubiquity of software. Yes, it plays a really critical role, but there have to be some fundamental shifts in software engineering to maintain DoD's competitive advantage. And we all love talking about software technologies, but no matter how innovative the software tech is, we can't affect the warfighter unless DoD acquisition practices and ultimately the entire acquisition ecosystem supports their adoption. And finally, places like Kessel Run, and we now even call them Kessel Run-like. So Kessel Run and Kessel Run-like organizations and cultures are emerging. The ability to go fast. These are sort of these high-speed organizational models that everyone wants to adopt. They use agile, DevOps methodologies, and the idea is to continuously develop and deliver software capability that adds value to the warfighter. So I think we're at a really critical tipping point. The stars are all aligned. OSD, the services, programs, and Congress are all getting on board. And this means significant changes in the Department of Defense culture and policies. So this is precisely why I've asked Michael, Forrest, and Andrew to join us, because I think they can really help us to understand what the future could look like and how we're moving towards these future states. So just the game plan. I've asked Michael and Forrest to just provide a very brief synopsis of the DIB SWAP study, and Forrest just to walk through just briefly the acquisition pathways and the acquisition enablers, the initiatives that he's been supporting in support of DIB SWAP. After that, I want to rapidly dive into the questions. I'm going to ask the panelists, what their key takeaways are from the DIB SWAP study. My second major question is going to be, what does it look like to really do software right? What are the most important things that we've got to do to motivate these changes? And then the third question is all about software factories. What have we learned so far? What are the metrics that we're tracking? And then there's a lot of questions on what model. How is this all going to scale? Are we looking at one enterprise model, or are we looking at programs that are going to build their own software factory? So I wanted to get perspectives from the panelists on all of that. And then finally, I'm going to ask about emerging technologies. How can we take something like AI and make sure that it gets into the right software pipelines and so on? So that's what the game plan is. So let me just set the stage. Recently, the National Defense Authorization Act, so the NDAA, directed the Secretary of Defense to task the DIB to undertake a study on streamlining software development and acquisition. So what I'd like is, if you don't mind diving in and talking, just providing a synopsis of what the major essence of DIB SWAP is, that would be great. That'll get us started.
Thanks, Anita. Thanks, everybody, for being here. Tom mentioned this was his favorite panel. For those of you on the second panel, I guarantee he'll say the second panel is his favorite when we get there. So he's not a man of loyalty. So let me just give you a little bit of background. As Beth said, the motivation for the SWAP study came out of the NDAA. It was actually primarily motivated from colleagues on HASC and SASC, who were trying to provide a vehicle for the DIB to provide input to the department on software acquisition and practices. As I mentioned yesterday, there's a bit of an anomaly for us because up to that point, we on the DIB had not done any major formal studies. And to be quite honest, there were 25 previous studies on software acquisition. So we did spend a lot of time trying to figure out what was new. We did something quite both different and in keeping with, I think, the primary message we were trying to convey around software, which was we did an extraordinarily iterative study. The study was very open. The working papers were published along the way. There was lots of feedback. There were an enormous number of people that were consulted as part of that study, including 10 specific work teams stood up in the Pentagon on various elements of the study and the processes coming out of the study to provide input. I'll tell you one thing that really helps for those of you who do these kinds of things. Our designated senior staff member in the Pentagon who helped support the study, a woman named Bess Dobkeen, who came out of CAPE. If you ever do a study that's mandated by Congress, have somebody like Bess on your team, especially when 80% of the way through the study, she goes to work for HASC. So being able to close the loop there was not a bad thing for the study. So just to sort of go through the litany, there were three fundamental themes that the study supposes or presupposes as part of its thought process. One, speed and cycle time are extraordinarily important in the way you look at modern software. And that does not mean that attention to detail, and that does not mean that a whole bunch of other things don't matter, but if you're not paying attention to speed and cycle time, you're not going to deliver the kind of software that the warfighter needs or that the back room needs. Second is that, and the phrase is, software is made by people and software is made for people, so people actually matter. So it doesn't matter what other processes you put in place. If you don't have the human resources to be able to do that, you won't get there from here. And third, software is not hardware, and not all software is the same. And I'll come back and reiterate that a couple times. And the reason in particular, as I said yesterday, I came out of an aerospace private sector background. You can think about doing crowdsourced software for anything you want. I am not going to ride on an airplane where the digital control for a jet engine has been crowdsourced. So You can decide how you want to do software, but not all software is the same. And on one extreme is highly embedded, highly coupled code to custom hardware. And on the other extreme is off-the-shelf hardware running off-the-shelf software. And you can't just take the recommendations and apply them uniformly across the space. There's a very important statement in the study, and the statement is that almost everything that we recommend in the study, almost all the observations that we make, almost all the suggestions for process that we change, you can currently do in the Department of Defense. There are enough OTAs and authorities and ways to get around authorities and special access that have been granted, on and on and on. But the point is, you should not have to be a hero or a heroine to do software in the Department of Defense. And so codifying the correct way to do software is an extremely important element of the study. And we did that specifically because, as all of you in this field know, if you go from one side of the river to the other, the Pentagon is always in a position of saying, my hands are tied by this and by that and by authorities, and the other side of the hill is always saying, I gave you this capability to do something and you didn't do it. And so striking that balance on software by saying, we don't need a special authority for software, we need a way to do software and to do it right, both from an acquisition and a process point of view. There are actually a listing on the board here, but the ultimate 4 lines of effort that came out of the study go like this. The first line was to refactor the statutes, regulations, and processes for software. And that means what are the acquisition pathways and what are the development pathways that should be done to create iterative, continuous software. The title of the software study is Software is Never Done. That was a particularly chosen set of words, not because we wanted to make anybody who'd been around for a long time feel like, oh my God, you're asking me to buy something and then you'll continue to ask me to buy it forever. But in fact, that is partially the message, that if you adopt a view that your software has a beginning and an end, you probably are not thinking about the application of that software correctly. There's another element of that, and we use as an example, and I'll use the example not because I want everybody to think we made a specific recommendation, but there are many programs, software-driven programs in the department that history and reality says we will be spending money on software forever on that particular area. It is really quite akin to the way a service will always have people and has an ongoing need for people. So an example of that, some people in this room have association with them. We will be creating and deploying software to absorb data from overhead assets, process that data, and make it available to the community from now until forever. And a metaphor that says the correct way to do that is to get $1 billion approved, spend 5 years spending $1 billion, and then as soon as you're done spending $1 billion, be late and go ask for another $1 billion for the next 5 years, where you will spend $200 million a year forever. Okay, a metaphor of spend $1 billion, get approved for $1 billion, decide what is development, then what is test, then what is deployment, then what is maintenance, versus the way we all do modern software in the private sector and the way many parts of the department are doing software now, which is to say, I'm going to spend $200 million a year. And some of the time I'm spending it on new features, and some of the time I'm spending it on fixing features, but I am going to spend $200 million a year, and that's what I should be approved to do. So that leads to new pathways for doing software, and it leads to new methods of approval, the so-called color of money issue. So that's the first line of effort. The second line of effort is to create cross-program, cross-service standard infrastructure that's available so that the start and maintenance of an ATO-able program should not be a hurdle. And you'll hear some of that in a lot of the conversations over the course of today. How do we provide, for all the buzzwords you want to think about, how do we provide containerized, cyber-assured solutions that are readily available for a new start as the standard offering? So that's the second line of effort. The third line is around digital talent. For those of you who have been in the cheering section for the Defense Innovation Board, this has been part of our recommendations on the broad area of digital talent from day one. So how do we create career paths? How do we create training? How do we bring people from outside in and inside out? A whole series of recommendations on both the people who actually do software and the people who are associated with the software project, the PEOs, the acquisition executives, et cetera. And then the fourth line of effort is around specifically changing the way we do software in those areas where the DevSecOps approach is the correct approach. And again, not all software is the same. So those are the 4 lines of effort. I will tell you, so that's sort of the background. Forrest is going to talk about the acquisition pathways. Let me give you very quickly just 5 quick observations about what's happened since then, and I know there's more of this. So,
Yeah.
First of all, it was and continues to be extraordinarily important that the sponsor for the program was Undersecretary Lord in acquisition and sustainment. Her visible and vocal support, not just to the results of the study, but the enabling us to go where we needed to go, work with who we needed to work, and deliver results. We also had enormously important help, both inside the Pentagon and from representatives in particular of SEI, Forrest, and the MITRE team, many of whom are here today. So just it was a real community effort. 4 things real quickly. No, we didn't mean embedded code should be treated like a medical appointment scheduling app. We did really mean there's different kinds of software. The difference in the business systems that the Pentagon used between what the Pentagon uses and the private sector use are extraordinarily small compared to the similarities between the business systems the Pentagon uses and the private sector uses. We went so far as to say that you should never change commercial software. You should change your processes to match commercial software. So, third, yeah, we really did mean DoD should see your code. We made a very strong recommendation that code should be made available to the DoD. You can always tell when it's a good recommendation when the two polar opposites of the equation complain. So the large-scale defense contractors don't like that, and the startup community doesn't like that. But read very carefully. We said that the department should have access to your source code specifically to be able to do vulnerability analysis. Not to take your code and sell it to somebody else, not to take your code and develop it for a different application, but specifically the only way, in our opinion, you really can do vulnerability analysis on code is by looking at the code. And the last thing was one of our most famous work pieces. No, that's really not Agile, because one of the pieces of work that we did was something called the Agile BS Detector, which is a guide for a program executive to test what happens when every program comes before him or her and says, oh yeah, I do Agile. So there's a series of questions to actually find out if people knew what Agile actually meant. So let me stop there.
Thank you. Forrest, just a brief synopsis on the acquisition pathways.
Yeah, so when we talk about acquisition pathways, really what I wanted to just briefly talk about was what's happened since the SWAP study. So that was delivered, I think, March, April this year.
Yep.
And what we've seen since then is really those recommendations being taken up wholeheartedly, all across the spectum. It's just been a wonderfully exciting and innovative time, I think, to be part of this initiative. So we've seen, as Dr. McQuade said, one of the main recommendations being that there should be a software-specific pathway. That's been something that's been taken up by Congress, so we're expecting that language to come out in the next NDAA, which is currently being finalized. But at the same time, the Undersecretary has also said we're not going to wait for Congress. This is the right thing to do, and we're going to get out there and get in front of it. And so for the last several months, what we've been working on within the Pentagon Mark Center, the OSD crowd and all the associated ecosystem stakeholders, has been designing what that software pathway should look like, that really takes the Agile principles in and makes them, as Dr. McQuade said, make it so that you don't have to be doing heroics to do the right thing, but this becomes, at least for those relevant classes of software, kind of a default and an easier path. So part of that is if you're used to the 5002, what we used to call the horse blanket, because if you want to look at it, visualize, it requires a giant poster that takes up most of your wall. Ms. Lord has really been after blowing that up, and trying to take, instead of one big monolithic approach, have several pathways. So depending on the technical work, you can march down an acquisition approach that really matches the technical aspects of what you're trying to do. And I won't go through all of them, but one of those, of course, is software. So for certain classes of systems, where it really makes sense, as Dr. McQuade said, not every software is the same. But for some of those, you'll be able to walk down a software pathway, which brings in a lot of the lessons learned from the SWAP report. And the other thing that's been going on in the meantime is the same 2018 NDAA that commissioned the DIB to go do the study Also set up a number of pilots. So OSD has had the advantage of looking at what the programs are doing as they start to adopt agile, lean, DevSecOps principles and use that as well to influence the pathway that's coming out. So I won't tell you all about it. There's a lot there, and it's currently being going through staffing at the moment, I think. But it brings in things like user engagement, front and center, that you have to, before you get to walk down any kind of acquisition pathway, your user has to be identified. You have to have an agreement that they'll be involved, that you get the chance to prioritize and get feedback from them as you go through. So no big monolithic programs where the user is not really clear. Secondly, that it's going to be iterative. So I keep saying, as Dr. McQuade said, he said all the highlights already, but software is never done, which really means that what we're after is not a birth to death kind of life cycle, but an iterative one, right? I continue to walk through this. I always have to be showing value, and so the pathway is really built around the idea that I don't care what your process metrics show. I don't really care necessarily where in the process you are. But the main proof of value has to be delivered in workable software that we can actually see running, and that the customer in the DoD has a chance to see what's actually there, what that quality looks like, what those capabilities are. Okay, so I won't go through the whole thing, like I said, but what we've done is it's been really valuable for me, I think, to be there and representing the SEI research. We've had the FFRDCs for MITRE as well. It's gone through many iterations. Ms. Lord and the rest of the chain has really reached out to all the different stakeholders within the ecosystem, I think. There's always more to be done, of course, but trying to make sure that all these different perspectives that need to be represented have the chance to weigh in. It's been war games, so we've sat down and kind of walked through it with a real program and had the chance to kind of try it out as a tabletop exercise. And now we're off and running, and the hope is at least that it's signed out as an interim policy by the end of this year. So we'll see. That's an ambitious goal. But the point about it being interim is that just like we're talking about agile software and being iterative, we want to get something out so that we can actually see it in practice. Obviously we've done the best to make sure that all the good thinking is there and this is the right way to go, but we'll see once it gets into practice. We'll have another set of pilots that are stood up to make sure that we actually understand how this works in practice. So the one thing I'll just leave you with then is like I said, it's been a really exciting time. It really does feel like somehow we're at a tipping point for, as Anita said, a very transformative look at software. And it's been exciting to see work not only at the Ms. Lord level and Congress taking this up, but at the program level, our friends in Kessel Run, at the PEOs and the services. I mean, PEO Digital has really retooled to take a lot of this into account, and it's just feels like there's a whole community that's working together on this. It's an exciting time.
Yeah, it really is. Thank you. So Andrew, I'm going to have you get us started with the questions.
Sure.
So the first one, I mean, from your perspective as the Chief Data Officer for Kessel Run, what are some key takeaways from the DIB SWAP study that resonate with you?
Hopefully my mic's on.
Yes.
It is. So I guess one thing I say to everybody, or two things really, are that there's some context we should all remember whenever we're talking about software in the DoD. Number one, the DoD is the largest organization to ever exist on the planet Earth. In other words, there's more people, there's more money, there's more facilities and effort going into the Department of Defense than any single organization ever, right? Including like all of ancient history. Had you worked in Google or Microsoft or Facebook or Amazon, you would appreciate how difficult it is just to develop software in those large organizations. Imagine now how hard it is to develop new modern software in the largest organization ever to exist, right? So that's one particularly critical piece of context I think we should have. The other piece is I came out of the intelligence community. There's nothing that industry is doing that the intelligence community is not. The distinction is who's doing it at scale and with what type of data flowing around where. That's the distinction. So anything you hear about neural nets, we were doing in the 80s, right? Anything you hear about restricted Boltzmann machines or backpropagation or any of the new modern technologies, we were doing that in the 80s too. So it's not that there are brand new techniques that we've never heard of. That said, FAIR and a couple of the new AI organizations inside industry are really doing some new innovative work, but we're taking all of that too, right? So the idea that we're so far behind and backward is actually wrong, right? The distinction is that we don't do things fully integrated down to the kind of edge, the way that you're using your smartphone today, in the same scale, in the same way that industry is doing. So I think those are two really important things to keep in mind when we think about how do we get to the state in the DoD where we are similarly, let's call it, infrastructurally situated, right? So I think that kind of from the SWAP study specifically, and I was taking some notes here as you were talking, I read it before, and the show value thing is one of the more difficult ones. And largely, I think there's a broader kind of question here about how software gets developed in industry. If you think about it industry-wise, it's all based on markets. At the end of the day, somebody's paying you to do something. As everybody who's ever taken basic economics knows, is money in commerce is it's a clearing function. It is it's a value vector, let's call it. So whether good or bad, right? Let's call it valueless, but at the end of the day, it's a pricing mechanism to say what we should do next. The Department of Defense does not have that internally. There's no such thing as like an internal value mechanism. For example, when we talk about infrastructure is such a big piece of what I am focused on, because if we cannot flow data around, nothing matters, right? And so when you say who is going to run that infrastructure and how are they going to use it, you look at Kessel Runs or some of the other organizations, Space Camp and others. If we want to utilize infrastructure, how is it paid for? There is no mechanism to do software as a service inside the Department of Defense from an acquisitions perspective. So you don't know what to build based on a pricing mechanism. You would only know what to build based on who's loudest in the room, right? So there's a couple of like provide value. It's hard to know what the value is, except unless in what you're talking to your customer. And in that case, your customer is on the battlefield and oftentimes unreachable. So, and by the way, they don't particularly care about helping you iterate your particular buttonology or things like that, right? They just want it done, and if you can't get it done, they're gonna go back to Word and they're gonna go back to Excel, right? It's just the reality of the situation. The Microsoft the Microsoft weapon system has worked well for the past 25 years, quite frankly, is what we call it. It's effectively.
That's what my colleague calls a self-denial of service.
That's right. But at the end of the day, we've planned more missions. We've done more overhead imagery collection and all the rest of that with Excel and PowerPoint in terms of managing and all this stuff than we have with any other one particular piece of software. And that's largely because it's hard to break, quite frankly. It's everywhere, right? It's absolutely everywhere. You're not going to go anywhere and not find it. LibreOffice is not your backup, right? Or something like this, right? So the kind of infrastructure things are kind of the big thing in terms of from the SWAP study.
Yeah.
I say there's no real way to do market clearing. So I can go all day here, but that was that kind of major thing I took out of that.
Good, that's great. Well, since you both already talked a great deal about DIB SWAP, I think I'm going to move to the second question. Forrest, I'm going to start with you on this one.
Okay.
So what does it look like to do software right from your perspective? And it can be a combination of, what does it take to do it right, and maybe even what are the most important things to really think about and get you off on the right foot?
Yes, yeah. So I think the two things I keep coming back to in a way are speed. I mean, I think that was one of the main things that comes out of the DIB SWAP study. And I always like to caveat that because I think sometimes some of the pushback comes and people say, well, we're doing very sophisticated weapon systems. I'm not going to be delivering daily, weekly in the same way that a Microsoft or a Netflix does. And that's absolutely right. But when you look at the timeframes that we're delivering on today, I think I've worked with a number of programs now and been able to see what they're doing, and even aiming to get that down to a yearly drop, let's say, where I really want to take that software, put it through all kinds of accreditation testing and everything else before it goes on to a plane, or a physical system. That's still an order of magnitude change over what we are able to do today, and it still gets to that idea of speed, trying to do this with speed. But the second part of that equation is that we do it with rigor and with confidence. And I think, again, one of the areas where I often see pushback on the SWAP study is everyone says, well, not everyone, but some folks will say, well, you're talking about speed above all, and that's the Silicon Valley thinking, and we're not like that. We need to have all the accreditation, all the rigor, all the testing baked in. And that's still absolutely true. But I think there's a lot of room for new technologies to be there. I think, we're trying to see where we can use automated testing, to do that kind of rigor early and often. I really like to say that a lot of what we're looking at with the types of technologies that the DIB SWAP study talked about is at least as much quality assurance as you would do in a traditional program. The difference is that you're not doing it all in a block at the end, but you're trying to find as much of it that you can do upfront and even in a daily build, or a weekly check-in as possible. And so I think that in terms of what it looks like, it's speed with rigor, speed with confidence,
with
and appropriate speed, maybe I should say too.
How about you, Michael?
I'm
Your
going to say
perspective.
three things. First of all, let's a quiz, and so don't anybody give me absolute assurance because I'm not sure I have the dates exactly right, but it's too good a story not to tell. So, 2 seminal events happened in 2001, followed by 2016. Anybody know where I'm going here? So in 2001, 2 things happened. The requirements document for the F-35 was finished, and the first iPhone hit the market. What happened in 2016? The IOC for the F-35 happened, and the 10th iPhone hit the market. So let's talk about how you do modern software. Okay, so had you even attempted in 2001 to describe the requirements for the 10th iPhone, nobody would have had any time for your conversation.
That's right.
Now, F-35 is an exquisitely complicated piece of hardware. I am not suggesting that we don't have requirements for it. But I am suggesting, to go back to what we said over and over and over again, for the right kinds of software, an iterative approach is clearly the right thing to do, and that includes the ability to get feedback. So Alex said something extraordinarily important. I can A/B test an app on a phone and get immediate feedback as to what the market is telling me to do. I have to find a way to get feedback on the software that I do in those areas and locations where I can do that. That doesn't mean I'm going to do A/B testing on pulling triggers, but I am going to do A/B testing on a lot of software in the Department of Defense, and we have to find a way to engage the user in doing it. So that's point number one. Point number two is a very, very strong advocacy for as much automated test as can be done in line with the development process. Bob Beeler, who runs OT&E and is an alum of the organization here, is a very, very strong advocate for that kind of modern change to the way we do what is currently tailgate testing on our software. So number two. And number three, I think, I'll put it out there as a sort of a thought piece. We can disaggregate software structures a lot, and we can decide that it's a much more open market as to who does a sort of multi-source capability for the way we integrate software into complex systems. Somebody has to pay attention to the architecture. So the architecture is both the architecture of where the data is going to flow, but it's the architecture physically of who talks to what. I'll put a stamp on yesterday's ADL presentation because I think it's extraordinarily important for us, not only from a technical point of view, but I think it's going to fundamentally change business models as we go forward, because you can't just have architectures evolve out of sheer chaos. So, and I think that's an important part of the study.
That's great. Thank you. Andrew, your perspective.
Yeah, I think no one would disagree that iteration is the key to kind of good software. I also would agree that architecture is important when we come to larger systems, and there has to be some intentionality to it, certainly. I think where it gets difficult is when you have competing parties. I think the major way that you have good software is you have a owner, somebody who actually owns and is responsible for success, right?
Yes.
You can have iteration, you can have good infrastructure, you can have all that. If you don't have an owner, it's going to do this forever, and it's going to be like many program offices in the DoD. It's going to bounce from owner to owner.
Yes.
That's one of the things that we see a lot, which is, I'm just trying to stay alive. Find me a new PE. Well, that's not actually delivering value. That's not actually finding a way to create something valuable for an end user. No one's actually responsible for it. No one's being held accountable when it goes poorly. So accountability, I think, is probably the most important thing I would say if you're going to build good software. That I don't care where you are, whether it's DoD or otherwise. I wouldn't necessarily argue it's more important in the DoD than anywhere else. I would say in healthcare, it's equally as important. In fintech, equally important. In many of the places that we see, for example, energy, go out to talk to PG&E, see how they're doing with their software right now. So, again, accountability and responsibility, something that I think we do have uniquely in the Department of Defense. I don't necessarily know if we have it at the right levels, right? I think we need to have a lot more accountability, but again, agree with everything you all said, but I would add that there's that human flavor to it that's absolutely necessary. I would actually argue a little bit with you here about A/B testing trigger pullers, right? And the reason is because if we think that A/B testing is a philosophical concept that is good towards optimization, there's nothing that should not basically apply to it. Now, respectively, I would say maybe we should do it in a simulated environment first, certainly. But there's value in understanding what the process looks like for optimization when it comes to really, really difficult things like that. And I think that the concept that we wouldn't apply what are more algorithmic techniques to that, I think there's a lot of people scared about that, right? Because there's this human element. We think that we can do some discernment better than anything else. I think that's not going to be true in the long term. I think in the long term, our systems will be able to do discernment better than humans. And I think no one would disagree with that. It's a question of timing. And then it comes down to, and then how is that optimized? So my intention here is not to go down the rabbit hole there, but
No, and to be clear, my comment was not a philosophical issue about where and when we shouldn't do it. It was simply that we can't do A/B testing when in the test a life is at stake.
Agreed.
So that's all.
Yep.
Okay. I'm going to move on to software factories because I know a lot of people, even yesterday, were talking a lot about software factories and how all that's going. So I'm going to start with you on this one too, Andrew. So what have we learned so far from Kessel Run, Kobayashi Maru, any of them? Level Up. There's a few of them that are off and running. And I know it's still early on, but maybe you can share what we've learned and some of the metrics that we've been keeping track of too.
So you'll notice a trend here in everything I say, which is your speed is only as fast as your infrastructure. So Kessel Run started a couple years ago. The reason it was able to go so fast is largely because we were working on NGA's infrastructure. They had done all the hard work in terms of getting to the cloud. No one has done it from scratch without riding on somebody else's hard work that wasn't necessarily recognized to start with. Again, we've been doing cloud and something like hybrid cloud in the DoD for a long time. So some of the successes are not really our own. A lot of our successes came from a lot of the hard work that, for example, and I won't pound the table for Pivotal, but they did a lot of work with NGA very early, years and years and years ago, to set the stage for this. And so when you talk about other groups, again, access to infrastructure is still a huge issue in terms of speed. So, and that includes us as well. So you cannot scale your service delivery speed, your iteration speed, if you do not have something like our continuous ATO. Now, our continuous ATO is largely the probably biggest driver of speed for what we've been able to do.
Yes.
What does that tell you? That tells you that the RMF ATO process is the critical key function that is limiting the speed of software. Now, rightly or wrongly, the RMF process is what it is, largely for security and safety reasons and other like that. So I don't necessarily, again, philosophically disagree with it. I think the distinction, though, is that for other software factories, one, they're not going to be able to go as fast if they cannot get to an RMF process that's very fast also, which means AOs like Danny have to take risk. They have to, or at least they have to understand what the risk is. And I think that's a big thing that a lot of people don't talk about, which is we are going to take more risk. We need to determine where that risk is going to be, as opposed to we're going to take less risk uniformly.
Right.
It's understand the risk, take risk in the right areas. That's what speeds things up. That's the big thing. So that's number one. Number two, for software factories, let's call them, they are not sustainable unless they're inside of a program office. If you are Air Mobility Command, or if you're Army Futures Command or otherwise, and you are not a program executive that can actually expend funds and do programmatic, like POM, and figure out the colors of money and all the rest of this stuff with contracting and PK and all the rest of that, you will not be successful long term. That's just fundamentally true because you don't own your software. You just don't. Somebody else owns your software, and they're going to own the requirements for it going forward. So there's a lot of these happening. We have these little spin-up software factories that are a bunch of, it's a small contract group where it's a handful of airmen or soldiers, sailors, Marines that they just pulled off the street that know how to code. Well, they're going to PCS. Some of these people are going to leave. There's not sustainability there. They don't necessarily have the ability to continue the, we talk about software is never done.
Right.
Absolutely true. Good software is never done. Bad software is done pretty quickly. So, at the end of the, right, exactly. So at the end of the day, again, if you actually don't own the programmatic funding lines for that, and you don't have people who are kind of long-term there to maintain it, or even if it's not like one person or a couple people long-term, at least you have a process for rolling that over with competent people. We're not going to be successful. And so I think I challenge a lot of these organizations which say every airman a coder. General Jameson at the A2 has said that. And I told her directly, I'm like, no, every airman a program manager, product manager, so they understand how to roll over and product manage these things long term. We need a core of people who know how to build. So for software factories,
Right.
they need to get integrated into PEs, and that's why I would argue Air Force, specifically Kessel Run, and why I joined Kessel Run was because we are a program office. And that sounds like really lame and boring, but again, having been a CEO in the private sector, I know that there's two things I care about, which are my money coming in, right? And making sure that I have the capability to actually change the things that I'm building, right? And those are what program offices uniquely have. So, I don't know. Did that hit all the right?
Yeah,
hopefully that hit all
that's
the right
great.
points.
Those are great insights. Forrest, how about you?
Good. No, that was perfect, actually. One thing that you said that I think that's crucially important is that, again, just like software, the infrastructure is never done. I really have this nightmare scenario where all these initiatives that are stood up build all the DevSecOps pipelines, the infrastructure is there, and then we say, okay, good, we're done with that. And then we'll be right back in the same position we are a couple of years down the line. Right. Your point about having this has to sit in a program office is really interesting, though. Now, I know that Kessel Run, for example, built an infrastructure with more bandwidth than you needed, right? So other programs are now riding on top. But how does that work in practice, though? I mean, is there some kind of a relationship between those programs and you? I mean, there's no way to get...
It's totally ad hoc. Yeah. I mean, right now, we're out there figuring it out, right? Yeah. It's not like clean, it's not repeatable, it's not any of that stuff. What we're trying to do, and back to my point about what are market clearing mechanisms inside the DoD is, for example, we have 20, 30 other program offices or other groups who are utilizing our infrastructure, right? How do we pay for that? Or how do they pay for that? Well, they don't really. So there's kind of this whole, if you build it, they will come portion of it, or you take the loss leader model and you say, well, we're just going to eat the overhead in order to get more people on so that we can kind of get our market solidified position, have our moats and all the rest of this stuff, right? That is a market-centric approach. Yep. So I think what we're seeing on the flip side is that from the acquisitions community, specifically like the SAF level, they're all trying to do this thing where they say, well, no, one cloud to rule them all, right? Instead of having to worry about these market clearing mechanisms, and in fact, I don't even know if they're thinking about that, but they're saying, no, we're just gonna have one group and they're gonna manage it all and it's all gonna be that. So what we're trying to do is say, let's let the markets decide to some degree, understanding there still really isn't a clearing mechanism, right, like a commerce mechanism, where on the flip side, we've got a new Bradley tank, new F-35, infrastructure, the cloud hybrid infrastructure for the DoD is the new Bradley tank, is the new F-35 giant program, which is being overseen by a bunch of people who've never run a giant private cloud, right? And so we are swimming upstream and trying to scream to people, no, if we have multiple, let's make sure we have a mechanism to figure out how we get the pieces and parts of the best and have a diversity, which is what we have in the private sector. We have a diversity of capabilities and not just jam everybody into one piece of infrastructure. And getting DISA out of the way and a lot of this stuff is what we have to do. These are hard, no kidding, congressional secretary level things that I don't see people fighting those battles on. And I'm in all of the top, the meetings with these people. I'm like, who is arguing that DISA should be doing their job better? Where's the global DNS? Where's the global certificate authority? Where all the stuff that you need to have a basic internet, right? They just don't exist. And so we're trying to build them, and other program offices are like, yeah, we'll play, but they have no plan for long term.
Yes. Right. Yeah. I was going to say, back to Anita's question, what have we learned?
Yeah.
I think one thing I've learned from observing is that these are highly expensive.
Yes.
And they take years to get stood up. I mean, if we're after programs being able to deliver capability with speed, I mean, one thing we certainly don't want them to do is every program to have to stand up their own infrastructure. So to the point that they can ride on ones that are out there that have additional bandwidth, that's, I think, exactly where the model is. But what I haven't thought through yet is who owns those,
Well, and that's the
those
point.
enterprise services.
Again,
right?
now it's a power battle for who owns the infrastructure. Because quite frankly, it's a really important place to be from a power structure perspective. Raytheon's trying to do it, BAE's trying, like all the major defense contractors, they're kind of riding it out, waiting it out, checking everything, and they're gonna come in real fast, say, we got the infrastructure, right? We got it. And then they're gonna be like, then we got all the data, right? Wrong. So no, it's my data. It's the persons of the United States' data. It's your data, right? It just happens to come from Department of Defense systems. It's not BAE's or Palantir's or anybody else's data.
Right.
It's your data, and you should care that the people who are actually utilizing it in war are the ones who own it, not these corporations and stuff, right? Which, again, former CEO, I want to own all your data too, right? But at the end of the day, it's the wrong way to think about this because this is, no kidding, public service. We're not doing this to make ourselves better. Sorry, I'm ranting now.
It's all good. I'd like Michael to weigh in on this
I want to
too.
own your code too. So. Maybe a slightly different thing, which is just another sort of thing to look out for. I worry a little bit when we use terms like software factory. So agree with everything that's been said. But when we think about these monolithic places where you go get software done, there's a bit of sticking to the knitting that has to happen here. And if you look at lots of sort of new innovation organizations, there's a tendency to say, man, they did that spectacular thing. They can do anything. And I think it's too early in the evolution of the new ways of doing both innovation and software. Kessel Run has done a couple of really, really fabulous things. The death of Kessel Run, when we decide to give them everything, when we decide that Kessel Run should do something that's a huge multi-year defense contractor kind of program. And so there's a watch out I have in there about software. I would rather have 10 small software factories appropriately provisioned, riding on all the things we've just said, than one which is 10 times bigger than everybody else. Because I think there's an ego that gets involved. And there's boy, I did that thing right, and look at me, I'm the golden boy, and everybody wants to come visit me and see how I do it. And boy, when you crash and burn on your first big program, the antibodies are worse than you have ever seen in your life.
Yep.
And so I think it's really important when we think about software factories as a
Yes.
term that we think about the right size and scale.
Sorry, and to that last point,
Yeah.
there are vultures waiting for us to crash.
There were vultures waiting for you when you were still doing the first project.
I know. But I'm saying the bigger we are,
Exactly.
Yes,
the easier it
that's
is
right.
for the major defense contractors to say, look, see what happened when you tried it yourself. We're going to do it right for you. And the reality is, if we don't have congressmen and women and administrators who know the difference,
Right.
then that's what's going to happen.
And it's hard because, look, you can't, the flip side of that is you get accused of cherry picking.
That's right.
Right?
That's right.
I mean, you did the tanker thing, and the tanker resupply mission. Boy, that took a very specific thing and a very easy piece of time. You cherry picked off of existing infrastructure. You didn't have to solve all the great. So you can't get accused of that. On the other hand, if somebody come to Kessel Run after doing a tanker resupply and said, "Can you redesign the whole AOC?"
We mean,
Yeah, but
that's
vultures-
exactly what happened.
Yeah, exactly.
That is what
All right, I'm done.
Oh, I know we want to make some time for questions, but I want to ask one more question, and it's the last one here, which is how do we incorporate emerging technologies into these software pipelines? We can use AI, we can use your favorite one, but these are often running, but how do we make time to say what's coming next and how do we position for, and think about how we're going to use these emerging
Everybody in the
technologies?
Department of Defense should spend all their money at SEI, and we'll figure that out for you. So look, I just very quickly, I think just follow the theme here. So you get it right in the moment. You get the best infrastructure you can do right now. But if anybody's sitting here thinking that the way we will do software and all the same tools will be the same 2 years from now as they are today, it's just not right.
That's right.
You got to have folks who are looking at how you integrate the engineering of new tools and new capabilities into the system, but you also have to be looking at how those tools provide value in the immediacy. So you
Exactly.
can't just sort of do a theoretical exercise on How do I add AI-derived software? How do I add AI cyber into my DevSecOps? You got to really think about who the user is going to be and how it gets done. So it just has to be integrated into the
I
engineering of the
agree.
system.
I agree. Forrest? Yeah.
I was just going to say, I think one of the reasons I'm so excited about this idea of a new infrastructure that kind of brings in appropriate automation and iteration and all the rest is that it becomes a lot more tractable to think about doing exactly what you just said, Anita. I mean, if I was thinking
Yes.
about kind of doing a program on a 7 to 10 year cycle and
Yep.
bringing in the technology at the same time, if that's how long it takes me to get the code out the other end, I don't know how I kind of manage
Exactly.
in the middle of it. But being able to do iterations, to bring in to bring in the code to be able to audit everything I've done so far, so I understand what the tools are doing and where I can insert the new technology, and then work towards small iterations where I can actually prove it out. I think it becomes a lot more tractable to bring in all kinds of things. So I think it's providing us the underpinnings to do exactly that.
That's wonderful. Last one.
Okay, so we all have AI products on our phones. So if you look at what an AI product is, let's call it, so it's some type of NLP or computer vision that's doing something for you automatically, like your route planning. You'll notice, though, that the good ones that last, that stick around, are features inside a successful product. You have to have successful products in order to actually integrate AI tools, capabilities, right? They don't exist on their own. They exist as part of features, right? So they are automation. They're what I call is basically feature automation. Everybody knows feature engineering in terms of changing the knobs, right? But feature automation is really where it comes from. And what do you need to do to get feature automation? Well, you need first a good product. And in order to get a good product, you have to have a good user base. In order to have a good user base, you actually have to have infrastructure, right? Here we are again. So a big piece of what I do as CDO, and as I'm trying to push us towards this AI future,
Yes.
it's making sure that, no kidding, I'm able to get the training data that I need, that I'm able to kind of close the loop on reinforcement learning processes if I want to do that. That means, again, my networks are good. That means my infrastructure is functional. One of the things, though, I think that we do have the opportunity to do, which I'm really focused on, is taking lessons learned from the past, let's call it 10
Yes.
years of industry and how we've done AI. And my computer vision company previously was all about actually doing 3D mapping in real space. So how do we take those same concepts and learn from what we did wrong in the first place in terms of getting product into people's hands and getting the data that we need and getting the metrics back and all the rest of this, and apply those without having to learn the hard lessons we did before. And again, it goes back to everything we're saying here. You got to have the infrastructure, you have to have good products, but you also have to be able to install and use modern techniques. For example, TensorFlow isn't ATO'd on Zipper. That's super silly, right? So getting things like that done, just to have the basic tools where, and I cannot stress this enough, where the data is. You can't do AI if you cannot actually do development where the data is. It's just impossible, right? And so that's again, we go back to ATOs and processes and all this kind of stuff, having the ability to actually inspect. And honestly, one of the biggest issues I have right now is people. I cannot hire machine learning engineers. I cannot hire even data engineers, data scientists and all that, because I'm getting paid the most in the DoD, and I'm getting paid what an SDE 3 is at Google, right? I've got colleagues of mine getting 750 right out of, that's you guys, right? You know this. You all have colleagues getting $1 million a year from Google or Microsoft or otherwise, and all compensated. DoD can't pay that, right? At scale. We can. We choose not to, right? It's just part of all of our crazy rules. So I would argue that one of the biggest things is people.
Let me follow up there if I could,
Yeah,
actually. Because
please
I
go
think
ahead,
one
and
of
then we're
the
gonna
one of the
take some
debates we've
questions.
had, as we look at kind of reinventing the workforce, bringing in these competencies, we've kind of gone back and forth. One is, yes, we can't match what Google would pay in terms of benefits and salary and all the rest. And at the same time, I think there's folks that have articulated that, but the mission is attractive. At least
right.
for some segment of the
right.
population, they would be interested in coming at least for a while because the mission is so important and kind of gets to an important place.
Don't get me wrong.
Maybe you're saying that's not so much true, though.
No, well, it's
I
true
think
and
that
it's
is
not.
true.
So the thing is, sure, it's true, but it's true for a tiny subset of the total population of possible machine learning engineers, right?
Yes.
So let's make this argument. You say, okay, take the population of let's say competent machine learning engineers, and you say, okay, of those, how many are U.S. citizens? Well, cut it in 3/4 and kick the 3/4 out. Okay, now you got a quarter left, right? Okay, so you got a quarter left. How many are ethically opposed to working for the DoD? Well, you're going to cut off some portion on like that. How many are now, even available, right? They're not already employed. Well, you're going to cut off about half of those, or probably way more than that. Now you've got the people who are available to be recruited, right? So of the people who are available to be recruited, are their incentives primarily money, or are incentives primarily mission and things like that? So again, you're just chopping slice, and then it's, can you actually get them through the hiring process? It's taken months to get people who are perfectly qualified through the hiring process. And they say, forget it, I'm just going to go work for a defense contractor and I'll come back and charge you 3 times as much. Okay, well, fine, I got to deal with that. But, at the end of the day, we're our own worst enemy in a lot of these cases. And again, when it goes back to how do we make risk decisions, it might be okay to use non-U.S. citizens to do some of this stuff. But we need to figure out how to make that work in order to access the larger population of personnel who can actually do these jobs. Or we're just going to get left behind because, honestly, our adversaries don't care. They're going to do whatever they got to do. The fact that we don't shows our prime position. The fact that we're fat and happy and don't have to do that is actually a risk.
I agree. All right. With that, I'm ready for some questions. We're ready for some questions. Heidi. Wait, do we have a
microphone?
Thank you. I'm curious to hear your perspective on, I will give you an actual example. I won't name the program, okay? But there are poor architectures that's designed well over a decade ago. Programs still ongoing, struggling, patching, and band-aiding. And I'm trying to figure out, how do you take a convoluted, poorly architected, heavily software-driven system of systems, which has to operate in a contested environment under attack, right? How does everything you're talking about apply to that? That's what I'm trying to
Are you asking me or
You can. Do you want to start?
Well, given that that's exactly what we're trying to do, the answer is difficult. With much difficulty is the answer. So you have lots of different competing interests. Of course, I would argue is the kind of primary one. My take would be eat the elephant one at a bite. Well, bite at a time. That's literally the only way we can do it. So I'll tell you kind of our process. Our process is we know the totality largely of what we need to do, for example, for the AOC weapon system, as an example, right? This is a system of systems that's large and old and patched together like you talked about, right? So the first thing was we have put it under a single organization, right? That's that responsibility piece. It's been there, but now we're trying to really codify that. So that's first. Second, prioritize what low-hanging fruit we can modernize immediately without breaking everything else, and doing it in a way that has flexible architecture.
Absolutely.
On down to the harder and harder engineering efforts, to the effect where you say, in many cases, we're not going to modernize them. We're going to completely obviate them with a completely new process of doing things, right? And obviously, I won't go into the details on the specifics. But again, not unique to DoD, right? Healthcare has done this. The space industry has done this, right?
Yes.
It's the same process. Eat the elephant one bite at a time. And honestly, I think the biggest thing is have people who have done it before help, right? You can't have a bunch of new people do this. And I think that's one of the flaws that we've seen inside the DoD is we say, well, if you're excited about software, come and help. Well, the reality is sometimes you need 60-year-old engineers who know COBOL to be able to do the right thing. And I love hiring those guys because they're way smarter than me about how to make stuff work.
Then you also have to justify the decisions you make. Like, of course, I'm never going to touch that floppy drive system. Not because I shouldn't replace it, but because, boy, it's really cyber secure because nobody knows anything about floppy disks anymore. So.
Okay, one more question.
So to ask you to open your crystal ball After the SWAP study, how does what your recommendations illuminate impact the way things drip down through OSD, through agencies and services, down to the person who is actually trying to get the job done? Specifically, in this case, how would it impact the work of the SEI?
Andrew, do you want me to go ahead? Oh, you go
No, I think that's exactly the right question, first off. I mean, I really believe that what we're doing is kind of so fundamental that I think this is going to generate the research questions that the SEI is working on for a long time to
Yes.
come. I mean, I think not a day goes by that I don't see some ideas where we need to focus our research there. I mean, I'll just pick an example that came up the other day. It was, if I'm really trying to move my testing to the left, how do I collect data all through that, and
Exactly.
put that together into a cohesive story? How do I do that in a statistically valid way? Whereas, today we're doing it all at the end in a bottleneck that we want to try to streamline. How it drifts down, that's an excellent question too. And one exercise we did as part of the SWAP study was to look at the length of the statute and then how that got interpreted by OSD and then how that got interpreted by the services and then and so on and so on. And so we're, I think, trying very hard not to repeat that experience, but that's a challenge.
I'm going to weigh in too on this one because this is near and dear to my heart and our SEI hearts and SSD. Betsy, we're trying very hard to have data from all of these things, understand the data, analyze the data, and have that be a feedback loop to our research programs. And I think for us, for SEI, that's a really important role to take on. So that's a lot of what we're trying to do with Andrew and Kessel Run, with Forrest and his important role with the acquisition practices and policy work, and with all of the DoD programs that we're working on, is how do we learn from this data and feed that back into our research? So I think that is what one of our important roles are.
Yeah, I would say two things also. I mean, just take a big step back. The essence of the study is, do I have sort of today available tool chains and iteratively think about the tool chains in the same way I iteratively think about the software? So there's a question asked before about how we get AI into the system. All of those things presuppose the capability of a place like SEI and other places. I mean, we'll push SEI, but that continuous flow of new ways of doing has to be a part of what drives the ability to execute what the SWAP study said. So that's point one. Point number two, which is a ask of all of you, which I feel sort of important. I think it's really important. So the kiss of death of any big study is at the end of a couple of years, everybody looks at the study and says, boy, all that stuff I was doing all along, it's right there in the study, right? The job that we all have is to not let that myth get propagated. I really was doing the way you said it all along, just look, and then nothing changes. So you have to help us fight. You can't let people say, the way I did software 10 years ago was the way you were describing software in the study, because that will happen. It's a big bureaucratic organization and people want to protect stuff. So it's important that we always question, in the same way we wrote this snarky little agile BS detector, it's important that we question all the time, are people who said they were, I mean, it's one thing if you say, look, there's a better recommendation there, I'm just not going to do them. I mean, it's a perfectly valid response. But when people say, I am going to do that and I commit to do that, and what they end up doing is justifying what they already did, you all need to help.
By the way, I appreciate your snarky thing. The snarky agile BS detector.
Yeah.
That's gone so viral. It's been great. If I could actually say one thing on that point is that
Last point.
Yeah, sorry.
Last point.
we're actively trying to get more SEI people at Kessel Run.
Yes.
So
yes.
I'm doing everything that I can to work with Anita and everybody else to make sure that great software engineers are part of our team and can feed that back.
That's great. All right. Thank you, everyone.